So homework 8 starts off, and actually the whole paper probably is, what they used to call algebraic symbol manipulation, and now they've renamed it to some other crazy name. What they want to get across is that when you solve it, even if it's not a number, you're still doing the same operations to move things. If I want to solve this for x, I want to move the minus y to the other side and the 5 to the other side, and so I have to do the opposite of that. So when I move the y to the other side, I'm going to add the y. The a is still going to be in front, but I'm going to have a plus y behind it. Same thing when I move the 5 to the other side. Since it's a minus 5, I'm going to make it a plus 5. That's going to leave the x all by itself. So on the second one there, I want to solve it for the s. It means I want to move the q and the r. So if I'm going to move the q to the other side, I'm going to minus the q. If I'm going to move the r to the other side, again, since it's positive, I'm going to subtract the r. And so s is going to equal p minus q minus r. It is going to be case sensitive, so if it's uppercase, you need to type it in uppercase. If it's lowercase, you type it in lowercase. So if I look at that third one and I want to solve that for a, well, this is a trickier one. If I want to solve this for a, what should I probably do?
Move the a.
I'm going to move the a because the a is negative. Remember they had that little trick when they did those ones where they had like 142 minus x equals 50? They moved the x first because it was negative. So if we move the a first so it's positive, we would have p plus a equals 4 minus b. So that's one thing you could do. It wouldn't necessarily have to be your first step, but it'd make it so you don't have to divide by a negative. So now if I want to solve it for a, I need to do what? Subtract the p. So a is going to equal 4 minus b minus p. And now the a is all by itself. Otherwise, if you didn't move the a first, just for those who didn't think of doing that, if I took the p and I moved my 4, I would have minus my 4. If I would have moved my b, I would have added my b, but then I would have had a minus a. And if I have a minus a, I end up having to divide everything by -1, which just changes all of my signs. So positive divided by a negative is going to make that negative. Negative divided by a negative makes that positive. And a positive divided by a negative makes that negative. It's not in the same order, but you can see everything has the same sign in front of it as when we did it over here. So a couple different ways you could do that, but on Alex they say, oh yeah, if that's negative, if I move that first, then I don't end up having to do that dividing. Not that it doesn't work. Then they get to the ones where you're doing the multiplying and dividing things to get the variables by itself. Here, if I want to get the x by itself, not only am I going to divide by the 2, but I also have to divide by the y. So I'm just dividing by the 2y, and then the x is equal to w over 2y then for my answer. Here, if I want to solve this for e, I end up multiplying by both the m and the g. And so I'm going to multiply by the m and the g. The order doesn't matter when you multiply, so I'm just going to put it mgh equals e. And again, it's case sensitive, so the h is uppercase and the m and the g are lowercase. So if I look at number 6 and I want to solve that one for x, the first thing I probably want to do is multiply by the x and the y to get rid of that fraction. So if I multiply by the x and the y, I have x, y, z equals k. Now I want to get the x by itself, so I'm going to divide by the y and the z, right? So the y and the z end up underneath the k. X is equal to k over y, z. So just like when we had those other fractions, I want to get rid of the fractions as my first step by multiplying by whatever's in the denominator, and then I can go ahead and solve. 7, 8, and 9, those are our two-step ones where we're moving the term that doesn't have the variable, and then we end up multiplying or dividing, and most of the time it's dividing. But in this case, if I want to solve this for x, I want to get the x by itself, I need to move this negative 16y to the other side, so I'm going to add my 16y. So I have 6x equals 4 plus 16y. I then want to divide by that 6 to get the x by itself. In this case, if I would want to simplify it, because all three of these are divisible by 2, I could reduce things down. I could say 2 goes in here twice, into here 8 times, and into here 3 times. And so I'm going to have 2 plus 8y all over 3. You could simplify it into 2 fractions and have 2/3 plus 8/3 y. Also, it would be the same answer. I usually just leave the one big fraction. So on number 8, if I want to solve that for s, the first thing I probably want to do is add the 8r, move that over. So 10s equals negative 5 plus 8r. Then I want to divide by 10. Now in this case, if I'm not going to separate them into 2 separate fractions, I can't simplify it because all 3 of them are not divisible by the same thing. So I could just leave it as that fraction like that. If I would separate it into 2 separate fractions, I'd have negative 5/10, which I could then put as negative 1/2, and then I'd have 8/10 r, which I could rewrite as 4/5 r. So it's just more work. So I usually just leave the fraction. I can't reduce it down if I leave it all over 10, and so I just leave it like that. Number 9, if I want to solve that one for m, the first thing I'd want to do is minus the n, right? So d minus n equals 7m. And then the next thing I want to do, divide by that 7. So m is going to equal d minus n over 7. Again, it's just one big fraction. If you type that in and you hit the fraction thing first, it's easier to get it typed in than if you try to type the top. You have to highlight it before you hit the fraction. So I usually just hit the fraction first. Number 10 here, we want to solve for a variable inside the parentheses. If my variable is inside the parentheses, you've got 2 different options. You could either divide by what's on the outside of the parentheses first, or you can use your distributive property first. It really doesn't matter. It's a matter of preference of what you like to do. On the first one here, I'm going to go ahead and divide by the n. If I divide by n, I'm going to have 6 plus y equals c over n, right? Then if I want to solve it for y, I'm going to move my 6 to the other side. So to move my 6 to the other side, I'm just going to subtract the 6. And my answer would look like that. Y equals c over n minus 6. I can't make my c look like it's big. Now, the other way I could have done it also is to get rid of my parentheses first, for those who like to do that. If I use my distributive property, 6n plus ny is going to equal c, right, using my distributive property. I want to solve it for y, so I would move this to the other side. So ny would equal c minus 6n. Then to solve that, I would divide by the n. And so y is going to equal c minus 6n all over n. I can just leave it this fraction, or if I separated it, the n's would cancel on that end one and it looked like the top answer. Either way is okay to put it in. So just kind of a matter of preference. You can either divide by what's on the outside of the parentheses first, or you can use your distributive property first. So number 11, what would you like to do first to solve that one? Divide by the 2, okay? She says I'm going to get rid of that first. So b minus 6 is going to equal r over 2. If I'm going to solve that for b, then all I have to do is add the 6 to move the 6 to the other side. B would equal r over 2 plus 6 then. So number 12, if I'm going to solve that for x, the first thing I might want to do is divide by m. These guys got really quiet. You came in and they don't have to talk anymore. X minus 5 then equals y over m. So if I'm going to solve that for x, I'm going to add the 5 plus the 5. X equals y over m plus 5 then for my answer. And the last 3, I think, have to do with those ones that have fractions in there. Usually if there's a fraction in the equation, we like to get rid of the fractions first by multiplying by what's in the denominator. In this case, I have a 6, so I'm going to multiply by the 6. I'm going to cancel it out from this side. So r minus p is going to equal, since I have s times 6, I'm going to put the 6 in front because it looks prettier. So 6s. All right. And then, of course, if I want to solve it for p, again, if we remember, since this is negative, we might want to move it to the other side to make it positive, right? So I'm going to add my p and move it over here. R equals 6s plus p. And now to get the p by itself, I'm going to move my 6s to the other side. So r minus 6s is going to equal p when I'm all done. And again, if you forget here and you move your r, you're going to end up dividing by the -1, which is just going to change your signs, and you're going to end up with the same thing. So on number 14, I want to solve that for d. The first thing I probably want to do is multiply by 6. They're just not going to answer anymore. Times 6. So the 6a is going to equal b minus c plus d. My d is positive, so that's good. I can move the 2 things over to the other side then. So I'm going to have 6a. What am I going to do with my b? Minus my b. And what am I going to do with my c? Plus the c. The d is now all by itself. So 6a minus b plus c. Because I'm at the bottom, it's not going to let me move my board up any higher. But I've got that fraction in again. Since I've got that 1/8 in front of the parentheses, the first thing I want to do is divide by 1/8 or multiply by 8, right? If I multiply by 8, that cancels that fraction out of there. So 8a is going to equal, and then I have 1 times the top, which isn't going to change anything. So b plus c minus d, right? This one says solve it for c. The c is positive, so that's good. We just need to move our other 2 terms to the other side. So I'm going to have 8a. If I move the b, I'm going to minus the b. And if I move the d, I'm going to add the d. That leaves the c all by itself. So 8a minus b plus d equals c. So a whole lot of algebraic symbol manipulation, which they changed all the names on. Alrighty.